Proszę Państwa, realizujemy dalszy program. Pierwszy wykład wygłosi przedstawiciel IBM, pan Peter Harrison.
Morning. Can everybody hear me? Good. So this presentation is going to be in English. I hope that's okay for everybody. So I'm going to talk about big data. Before I start, who's heard of big data? Show of hands, please. One. Excellent. So at least I won't be telling you something you already know. So if we want to know what is big data, who can we ask? Who would you ask? Come on, some answers. Well, we ask Google, of course. Google knows everything. So I don't know if you can read that. What is big data? I asked Google this morning. 1 billion answers. So a little bit of a challenge to work out which one is the right one. So I'm going to give you a definition from IBM. What do we understand by big data? So what we're talking about by big data is data that you cannot process with the normal methods that we deal with data. Due to the size of that data, the structure of that data, it's too big, it's too fast, or we just can't work with it with normal database management tools. To find out any useful information from this data, we have to treat it in a different way. So what are we talking about? We're talking about all types of data with a lot of volume. That's why we call it big data. But not only about volume. And I'm going to talk a little bit more about what else defines big data later today. So in this data, there can be lots of information that is valuable for our businesses, for our government. But it can be difficult to find that information, and it's often extremely time sensitive. So for example, we're talking about sources such as social media, log files, machines, and this data is only useful if we look at it now. If I'm looking, for example, at location-based data for a mobile phone, I can use that information if I've got it when I'm here. If you're going into a shop, for example, I can give you an advert that's relevant for you. But if I send it you in 4 hours' time, it's probably not relevant anymore. So we're talking about a variety of data as well, looking beyond the traditional data stored in databases that companies deal with. So, firstly, the traditional data we've got, there might be more and more of that. It's structured, and we deal with that with traditional database management tools, relational databases. But then there's other types of data we hold in the corporation, which are not so easy to deal with. Secondly, machine data. More and more we're seeing machines are generating lots of data. Your engineers, this is important for you. That data is very useful to optimize the way that we manage those machines. But that data comes very fast. There's an awful lot of it. And we need to deal with it when it arrives. Next, social data. Data out there in the social media. How many of you have got an account on Facebook? About half. If I'd have asked that question even 2 years ago, I probably would have seen maybe 1 or 2 hands, and lots of people saying it was Facebook. If I asked that question in about 3 years, I reckon every single person in this room would say, yes, I've got one. And finally, the content that we have in enterprise. So we're talking about documents, emails, comments written by people all over the place. Very unstructured, lots of variety in how it's stored. Is it an Excel? Is it a Word document? Is it an image? Is it a text file? And an awful lot of it. Typically, in most corporations, 80% of the data that they hold, 80% of the disk space, is unstructured data. A bit of feedback on this microphone. So there's a lot of value in this data if we can find out what to do with it. But first, let's talk about social media. Beijing Olympics and Twitter. So here, there were 6 million users, 300,000 tweets a day at the time of Beijing. In London, 500 million users on Twitter, 400 million tweets every day. So you can probably work out that's 83 times as many users, but more than 1,000 times as many tweets. This is growing really fast. That's 4 years difference. And we've multiplied the number of users by more than 80. And the amount of tweets by more than 1,000. So social data is one very important aspect when we're talking about big data. Tweets, we already heard about. Facebook, not very popular yet, but becoming more and more popular every day. And YouTube, lots of video data, huge volumes every day. But it's not only about social data. Many definitions of big data just talk about social media. But we're also talking about machine data. From, for example, RFID tags, smart meters. 75 million of them out there, and it's going to be billions rather soon. Mobile phones. How many of you got a mobile phone? No hands? I don't believe you. I may not look that old, but when I was a student, nobody had a mobile phone. They didn't really exist. We had bricks that you could put in a car, but there were no mobile phones. Now, 4.6 billion of them. Hundreds of millions of GPS devices. They can be used to track you, if you've got one in your phone. They can track cars, they can track inventory, they can track all sorts of things. And more than 2 billion people are on the web. And that's going up very fast as well. So we heard earlier today about cars and the 150-year history of the internal combustion engine. The web was invented in '94, and already we have 2 billion users. 25 years. So let's look at RFID. So in 2005, there was 1.3 billion RFID tracked. 2010, 30 billion of them. And that's growing faster and faster every year. These things generate a lot of data. For that data to be useful, we have to do something with it. Let's take another example. Electricity company. How often do they read meters in Poland? Once a year? Sometimes twice a year, sometimes never. So if we're talking once a year, for 10 million customers, we have 10 million records. If we increase that to once a month, 120 million. Increase that to every day, suddenly we've got a little bit bigger number, 3.5 billion. But with a smart meter, we can read that every 15 minutes, for example. 350 billion records a year. That's useful to electricity companies. They can predict more accurately when they need to generate electricity. Electricity is not easy to store. Either you use it or it drifts away. So this is very important information for them. With a meter that you read once a year or twice a year, you don't have that predictive capability. If you read it every 15 minutes, you've got real-time information. But you've got a little bit more data there than electricity companies are used to dealing with. You need different ways to deal with it. They cannot afford to spend 500,000 times as much as they're spending now on storing that data. But this data, not all of it is new. A lot of it has been around for a long time, or we've had the capability. Why aren't we using it? Why haven't companies and universities and institutions been using this type of data? Well, I liken this to this guy. What's he doing? Searching. You may not see it. Searching. Yeah, he's not going to the toilet, despite that it might look like that. He is panning for gold. California gold rush, the stuff was lying in streams, easy to find, like data in traditional storage. We have it in a database, easy to get, quite easy to extract value out of that data. But how does it work these days with gold? They are mining gold where the amount of gold in the data, the dirt that they're bringing up, is 1 part in a million, or 1 part in a billion even. And this is what they're using now. Huge technology to extract the valuable stuff from all of the rubbish that you've got. You need different technologies to do that. We can't any longer just pick it up off the floor. So producing the data is very easy. Trying to make sense of that is not. Nowadays, still we find companies are starting to realize what people write on Facebook and Twitter is important. So they employ some people to sit there and read it. Now, as we've just seen, 600 million tweets a day. A little bit hard to sit there and have somebody read it unless you employ everybody in Poland, which isn't very practical. So what we're seeing, this is a quote from CNBC, data is the new oil. It's dirty, it's difficult to use in its raw form, but if you can refine it, you can get a lot of value out of it. But what are the challenges that companies are facing doing this? Well, it's expensive. If you use traditional storage, typical total cost of storing data is about €5,000 per terabyte per year. That cost is falling every year, a little bit. Maybe 10% year on year, storage costs are falling. But the volume of data is increasing maybe 300% year on year. Some of you may study a little bit of economics as well. You can work out that that equation does not work if you still want to make money. How to understand this data, how to integrate it. Take all that data that's coming from social media, all that data that's coming from machines, all the data that we have in traditional databases, and bring it together and make sense of it. Traditional technologies are not very good at doing that. If we run a query over 100 billion records, maybe you'll get an answer tomorrow or next week. But if we needed to know who's in the store right now, that's not very useful. But the opportunity is there. If you can extract insight from this data, you can get a lot of value. You can start to understand more about your customers. You can start to understand more about your products. You can start to understand why things are breaking in your machines. You can start to have greater understanding of your mechanical plant. But you need a different approach to do it. So what can you do? Some examples of what you can do with all this data that we're getting. So really there are many. I've only got a few on this slide, but it can be used in healthcare. I'm going to talk a little bit more about that later. But typically, traditionally in a hospital, in the ICU unit, for example, a baby is plugged into 10 or 15 sensors. And once half an hour ago, somebody will come around and look at those sensors, look at the graphs they're drawing and see if it looks okay or not. And maybe they'll have a threshold alert so that if something's going wrong, they'll start pinging and somebody will run a little bit quicker. But imagine if we could monitor those sensors and not just notice the peaks when it may be too late, but aggregate all of the data from them and in real time identify patterns, identify a risk, and react much quicker. Well, we're actually doing that. It's not just a, let's imagine this is happening. And in that way, they are able to predict life-threatening conditions for premature babies 24 hours earlier, which, as you can imagine, makes a big difference to their chance of survival. In retail, multi-channel shopping, we can look what people are looking at on the web. What are they doing in the store? What products are they interested in buying? Companies like Allegro do this all the time. That's how they know what to recommend to you. finance, banks, insurance companies. They're very interested in how you're spending your money, where you're spending it, and making sure that you spend some more. Log analysis. So all those machines, all those servers are producing phenomenal amounts of data. Terabytes and terabytes of it every day. Most companies these days create those files and then throw them away because they don't know how to deal with it, they don't have the technology to be able to analyze it, and they can't afford to keep it. Security. There are lots of video cameras all over the place, and more every day, but analyzing video signals is quite hard. For some applications, terrorist activities, anti-terrorism, then it's important to be able to identify things automatically, spot people who are trying to hide. For traffic, and Jarek maybe can talk a little bit more about smarter cities later, so I'm not going to say more about that right now. Telecoms. Telecoms, we could think they already deal with big data. They get billions of phone calls every year. That's quite a lot. But the opportunity is there when they can start to use much bigger volumes of data. If you've got a mobile phone, it's talking constantly to the base station, what's called a location update. Depending on the network and depending on where you are, that might be every 15 seconds, every 3 minutes. But multiply that by 15 million subscribers, and you've got 50,000 such events every second. Those are useful for mobile operators. They can use that to target advertising. They can use that to track where people are going so that they know where they should be investing in their network, so they know where they can put more power or less power into an antenna. So that they can detect if there's a fraud, if there's a SIM copy. If I made a phone call, or if my location is in Bielsko-Białej, and 5 minutes later there's a location update saying I'm in Warsaw, that probably means somebody copied my SIM card. Search. As we've seen, ask Google. Great solution to everything, but if I ask Google what is big data, I get more than 1 billion answers. And that in itself is a big data challenge. How do I make sense of those billion answers? How do I extract the one that I want without reading through all 1 billion of them? For manufacturing and engineering, as we heard, machines generate a lot of data. As the machines become smarter, they can generate more and more information that tells us, are they working properly? Is there a tendency to go wrong? Can we predict more accurately when something is going to break so that we can react before it does? Trading. Of course, traders very interested in what's happening in the market. If we can predict more accurately than the next person which way the market is going, we can become very rich. Fraud is a problem in many industries, in banking, credit cards, mobile, internet. Anywhere we are, fraud is a risk. The more that things become interconnected and the more that they become electronic, the easier it is for people to do fraud. You don't have to anymore be an expert forger. You just have to be quite good at computers. Retail, for predicting when customers are going to leave, how are they going to stay, what do they want to buy, what is the next best offer that we should offer to people can help companies to make more money, which is what they want to do. So, in summary, there are lots of uses for big data across every industry, many applications. We just have to take it seriously. So, the possibilities are there. Some of the successes are possible. So, for example, I mentioned the case of security. Governments with big data technology can analyze acoustics. What do I mean? Phone calls. It's milliseconds. Rumor has it that the US government listens to every single phone call in the world. Whether or not that's true, I don't know, but certainly the technology nowadays enables that. Utilities. Avoid power failure. Is that important? I hope so. I mentioned the case before. Hospitals can use this to monitor devices in their ICU unit to identify life-threatening conditions earlier and more accurately. Retail are able to improve the speed that they can run queries to understand their customers, and so on. So I'm going to give some examples where this is being done. Let's start in Poland. Euro 2000. You can find out more about this on the web. Just type in Google Euro 2000 IBM, and this will come up. So we did an analysis of what people were saying during the time of Euro 2012 about the cities where that was hosted in Poland, Wrocław, Poznan, Warsaw. So we can see here the positive comments and the negative comments. That's the first two. I know this is a little bit unreadable, but you can find the original on the web and see what's happening here. So in the top pie chart, that's the positive comments. The bottom one by city is the negative comments. The red one was security. People were complaining about security. But this is information on blogs and on Twitter in a variety of languages, and it's free text. Not so easy to analyze. The second graph shows the volume and the net positive, negative. So the steeper the curve, the more positive. The longer the curve, the more comments on Twitter. And then we have what we call a tag cloud. What are the words that people are saying in different cities? And we can identify some interesting patterns there about what people are saying in different places. In Wrocław, we're talking about Spain for some reason. Another example there, Vestas. This is a company who makes and places wind turbines, one of the biggest in the world. As you probably know, wind turbines are expensive to build and expensive to install and expensive to maintain. The decision where you put it to maximize the output and minimize the chance of it breaking is worth millions of dollars. But to work that out, you need to analyze a huge amount of data about the weather, the wind speed, the temperature, prevailing wind, maximum wind, and all of those things. If you put it somewhere that's too windy, these things break. If you put it somewhere that they're not windy enough, they just don't generate electricity. So to do that, they are analyzing 2.5 petabytes of information. And with big data technology, they're able to bring that results within hours instead of weeks that it took them previously. And they're predicting that's going to grow to 6 petabytes of data that they can analyze so that they can get it accurate down to 100 meters square, whereas previously they were working on 5 kilometers square. A lot can happen in 5 kilometers. Traffic. We can monitor cars, either because they have a device in, and we can monitor where they're going, or by monitoring the mobile phones of the people in those cars. So we can predict where traffic bottlenecks are going to be. Several cities we are working with are using that to optimize public transport, to optimize road building, bus route planning, and I think Jarek is going to mention a little bit more about that. Hospitals, healthcare. UIT are using this, as I mentioned, in the neonatal department, monitoring patients in order to reduce fatalities. So big data can save lives. Another example, the Marine Institute of Ireland, they are monitoring data to predict floods and predict tides in order to have a more effective warning system. More effectively spend money, and again, save lives, make shipping more efficient. The University of Maryland is looking at meteorological data, satellite images of bushfires, wildfires, to predict where those fires are going to be, how they're going to spread. Huge amount of data from many sources. That means they're more able to predict how to tackle these fires, where they should put the resources so that they can save property and save life. Insurance company, they're able to predict, using analysis of their customer data and social data, which customers are likely to stay with them, what those customers would like to buy, which customers are likely to leave. So they can make more money out of this by keeping more customers. So Fiserv, this is a financial services company who provides credit card solutions. They're able to look at those to predict the transactions that are going to happen and make their system much more efficient using big data techniques. Cisco. May have heard of this company? So they're using big data technology for managing infrastructure. So I mentioned earlier, log file analysis. They're looking at the logs coming from all of their infrastructure to automate maintenance and make that more intelligent. Traditionally, maintenance of hardware is very simple. We say, well, on average, this thing breaks every 4 months, so therefore we'll check it every 3 months and hope that we get it right. Which works most of the time, but it's quite expensive and sometimes isn't accurate. We can, by monitoring those things, predict much more accurately where we should be spending the time. A European university is generating their own electricity. Why? Because previously they were getting 7-figure electricity bills. Tens of millions of euros. So they started running their own generators. But they needed to do that in a smart way. So they are using big data techniques to gather information about electricity use across the university so they can better predict when they need to generate the electricity, where they need to send it, and identify where there are problems. Procter & Gamble. They have a lot of internal, unstructured data. And they were able to implement enterprise search capabilities to search through all of that internal data to find the information, enable their analysts to save a huge amount of time when they're looking for something. Here's a telco company, Globe. They're using real-time analysis of where customers are, who they're calling, when they're calling them, from when are they calling, what data services are they using, to better predict and target campaigns. The challenge they had, most of their customers are prepaid. With prepaid, you don't have the traditional information about a customer. You don't know their name, you don't know their address, you don't know their demographic. But telcos have a lot of information about those customers from looking at who they're calling, when they're calling, where they're calling from, where are they moving. And they were able to, using big data, predict when customers are likely to leave by looking at their past behavior and other customers who have left, so that they can target those customers with a good retention offer. They were able to improve their retention and their retention campaigns by 600%. huge efficiency saving in terms of how they're spending money. And at the same time, they reduce the cost for those campaigns by 95%. Another telco, UFO. They had a problem with customers leaving. And keeping the high-value customers is always a challenge for telcos. It costs a lot of money to attract somebody to become a customer. How do we do that as a telco? Give them a phone. It's great. If somebody gives me an iPhone for free, I'll become a customer. But as soon as my contract's expired, go and find somebody else who will give me another phone. So telcos want to keep the high-value customers and make money out of them. Using prediction, they were able to improve the response rate of their campaigns from about 25% to more than 50%, and reduce their churn by 15%, increasing their revenue by 30% year on year. Another telco in India. India has a lot of mobile users, but they don't spend a lot of money. But they are processing 58 billion call data records per day. 58 billion. That's a lot. Previously, they had a huge amount of infrastructure to do this. Can you see it? Because this screen's gone black. Still see it here?
Yes.
So that's good. And it was taking them 12 hours to process those CDRs. They reduced that time from 12 hours to 1 minute. And at the same time, reduced, in fact, to 8 to 1, the amount of hardware they needed to do that. And they're also able to use the same data and the same techniques to predict in real time what customers are doing and monitor what is happening on their network. And finally, law enforcement and security. So video surveillance, wiretaps, phone calls, emails. As you probably know, the US government had a problem with terrorism. They still do, and we have been working with the US government for many years on an approach how to analyze that to predict, identify, prevent terrorist activity. That's really all I can say about our work with the US government. Obviously, a lot of it is highly classified. But here's another company who isn't the US government, Terra Echoes. This is a private company who is involved in security and surveillance. They're using surveillance to watch what is happening at events, at classified sites, to be able to identify when those sites are at risk. They can analyze the data, including acoustic data, video data, in real time, show the security staff at the labs the potential threats, and at the same time eliminate the non-issues. And finally, this is a retailer in Brazil. If any of you can speak Brazilian, you can read the comments there. They have implemented smart hangers. All of the clothes in the store are connected to Facebook. And you can like that particular suit. So they're able to track who likes what in their stores. And using that data, they can predict where are the most attractive places in the store for which type of people. What is the demographic of people who are interested in that type of clothing? Is that important? It is if you're a retailer. Floor space in a department store is expensive, so we want to be able to predict what's going to sell. Where should we put it to make it more effective in selling? And I'm going to talk a little bit about one of the cities in Europe. City in motion. Hope you're not going to say yes as well. No, we did check actually, I know it's not. So this was a joint venture, first of a kind project that we did between the city of Istanbul and Vodafone Istanbul, using anonymized mobile location data to be able to track the movement of people and vehicles. Any of you been to Istanbul?
Yes, I was.
Yes, you was. How was the traffic?
I don't remember, I was a child then.
Traffic in Istanbul, I was in Istanbul 2 weeks ago. The traffic in Istanbul is really bad. It's really bad, in fact, at 11 o'clock at night. Unfortunately, my flight landed at 5 p.m. It took me an hour and a half to get to the hotel, which was 5 kilometers away. So Istanbul has a traffic problem. It's a very fast-growing city. It has 15 million population, and it's growing by 1 million a year. So that traffic problem isn't going to get any better. So the city of Istanbul is investing in public transport schemes, and what they want to know is where is most effective to build that. And they're using this project to be able to monitor where people are. So we can look at identifying where people are, which cell are they in, building time density. So we can look at any time of day, what is the density of people, how many people are in each cell. But not only that, we can monitor where people are moving around and use that to predict where people live, where people work. That's quite easy to do by looking at the location data from the mobile phones. The place that you are between 2 a.m., or your phone is between 2 a.m. and 8 a.m. is quite a good predictor, maybe not 100%, but quite a good predictor of where you live. Similarly, where you are between 9 a.m. and 5 p.m. is quite an accurate predictor of where you work. They have trouble with me. But they were quite accurately able to predict where people live, where people work, when people go to work, what journeys they take. Now, all this data is anonymized. They don't know who are the individuals. That's a very, very important aspect of this. We're not spying, it's not Big Brother tracking where people move, but using that data for the city, understanding the journeys that people make, where they go from, where they go to, at what time of day, is critical for them to plan the public transport so that it works well. So they're able to do that, mapping those location data onto traffic plans of the city to see where is the congestion. This is at 8:30 a.m. You can see it's red for most of the city. It's going to stay red most of the day and most of the night. There is a video of this on YouTube you can go and find, and you can see this moving. I'm not going to play the video here because I'm suspicious that the technology will fail me like that screen just did, and then nobody will see it. But they can track this in real time throughout the day and throughout the night to watch what's happening with the traffic. And also use that to predict what's going to happen with the traffic. What impact would it have if they close a road? Or if there's an accident? Or if they put a bus lane? Or a new train stop? So one of the things they're using it for is bus stop placement. Finding the feeder routes for the new metro line that they're building, where should they put them? Why? Because these things cost money. Cities have a limited amount of money. They can reduce the amount of operation expense by up to 40% by optimizing those bus routes. What's the OPEX on a bus? It's sitting there in traffic, burning gasoline, or maybe LPG, if we're lucky. Also reduce the demand. The people want a bus, but they can't get to it, so they're able to satisfy that unmet demand. And at the same time, reduce the travel time. From an average of 37 minutes to 10 to 22 minutes. That's a very significant saving in terms of the time that you're spent sitting on a bus in traffic. That was my last slide. So, message to all of you, think big. Think about big data. It is important. Whatever you're going to do, it's becoming more and more important every year. How are we for time? Do we have time for questions?
Dziękuję bardzo panu Harrisonowi za ciekawy wykład.